Hello everyone, my name is Daniel Mohr and I'll talk about multi-cluster observability today. So my talk is mainly about how we do things at Red Hat, both for our internal users, for the managed services we run for customers, and also for the products we sell in regards to multi-cluster observability. Everything we do is based on open source. It is open source actually, all the code we're contributing upstream. And we're using that then for our products, which we run as managed services and sell for self-hosting. So let's look at what I'm going to talk about today. So first, I'll quickly look at the single cluster use case, because also already there will be a few challenges if you run it in production, which we solve partly with a project called Thanos. So I'll introduce Thanos a bit for everyone who hasn't heard about it. From that, Thanos also plays a big role in our multi-cluster use cases. So we go to the multi-cluster observability, look at the Red Hat use cases, how we leverage multi-cluster observability for answering different business questions. We'll look at monitoring as a service. It's basically the infrastructure we provide for our internal teams, and also which we then ship for customers. Then we'll look at, so when we think then about gaps in open source, there's a new project I want to talk about, which is Thanos Operator. And last but not least, I'll also look at comparing do-it-yourself solutions versus some existing vendor solutions. So I'll mainly talk about metrics today. We also have partly already integrated logs and traces into our offerings, but with logs, you can already go, with metrics, you can already go very far. And this is the essential basis which you need for these kind of business questions, because they're kind of cheap to store, they're structured, they're perfect for analytics. And you usually start with metrics. So who am I? I'm an engineering manager at Red Hat. I'm part of the observability group. I'm currently responsible for our multi-cluster observability team, which is basically delivering our advanced cluster management observability product. And I'm responsible for the in-cluster monitoring team, which is basically the team which delivers the core components for monitoring in OpenShift. I have a background in software engineering. I've worked in automotive, in industrial manufacturing, in market research, and I've led DevOps and SRE teams in the past. Good. So single cluster observability. So this is how a usual setup looks like. You have some monitoring system which scrapes a few targets, so applications or system components. It includes usually a time series database, which is then used for querying, for alerting, forwarding alerts to your favorite messaging system like Slack or PagerDuty or something. So in the single cluster use case, you usually have really the full metrics cardinality, but you usually only store it for a short time because you don't want to have these large storage provisioning on your single clusters. So the use cases typically are really local alerting for this cluster, short-term querying over usually maximum of 2 weeks or something, and really debugging, going into detail, looking into the cluster when something goes wrong. But if you run single clusters in production, where maybe multiple teams access this cluster, you have maybe an SRE team running the infrastructure, you have development teams building applications running on that cluster, you already run into a few challenges with monitoring because they interfere with each other. So let me quickly introduce a project which we use for solving some of these challenges. This is Thanos. So hands up who has already heard about Thanos? Who used Thanos already? Okay. So Thanos is basically a scalable Prometheus. It's sharing a lot of code with Prometheus, especially the APIs. And it's built for being horizontally scalable. So it has multiple components. They can be deployed in a highly available fashion. It provides usually a global view of your metrics. It's optimized for long-term storage. So we use it up to 3-4 years of storage. It provides components for downsampling, for compaction, in order to reduce the size of your data. And it has APIs for multi-tenancy usage. So let me quickly look at the two architectures with Thanos support. So this is the original Thanos architecture. It's the so-called sidecar architecture. So you basically have, switch here. You basically have your sources here, your Prometheuses on clusters. You run a Thanos sidecar besides them, which does a lazy upload to object storage of the metrics which are here. And a compactor is going to compact these things, make it smaller. And when you query, the Thanos querier basically decides whether to query directly the source Prometheuses through the sidecar using the Prometheus remote read API, or query through the store gateway, the object storage. And then you can have a global alerting using the Thanos ruler and forwarding alerts to Alert Manager or to some dashboards. This is for us, the more interesting architecture. This is the so-called receive remote write architecture. Here you have your source Prometheuses on the left side. This architecture is optimal in the case where you don't have full control about your source clusters. Here you basically only need to add a configuration to your Prometheus for remote writing things to a so-called receive hash ring. This is just multiple instances of the Thanos receive component forming a quorum and accepting the writes. The rest is pretty similar. It writes to object store. In the case of query, it either queries from object store or from the local storage of the receive hash ring, and you have a global ruler. So this is the architecture we mainly use with the multi-cluster use cases. But let's first go back to single cluster. So again, this is your typical setup. Here you have a Prometheus, you have an alert manager, you have workloads, which you scrape. But as I said, there are multiple teams working on that. They maybe are interested in different metrics. So there's an SRE team looking at platform metrics. There's a development team looking at the metrics of their workloads. And they basically want to have their own monitoring stacks. So what you usually do is you have multiple monitoring stacks and multiple namespaces. Sorry. Right. But then there's usually the question, yeah, maybe I want to correlate my application metric with a platform metric. I want to query that at the same time. I cannot do that because I don't have access to the platform monitoring, for example. And this is where also Thanos components come into play for us. We just deploy a Thanos querier and a Thanos ruler additionally on the cluster, and they basically act as a federation layer between everything. We still can have also global alerting. So teams can still access their own monitoring stack, but if they want to query across stacks, they can just use the Thanos querier. And this is actually how we also deployed in OpenShift. So this is a picture from the official documentation of core OpenShift. We have here separation between two monitoring stacks. There's platform monitoring on the left and user workload monitoring on the right. We have here a Thanos query and a Thanos ruler for the use cases which I've just described. Good. Let's look at multi-cluster observability. Typical setup looks like that. You have many clusters you want to monitor. They somehow export their metrics to a central location. Usually call it a hub, where you have a monitoring storage system, where you also have alerting, and where you have additional services which also access that monitoring to answer some questions. And usually there's object store involved for long-time storage. In this use case, you usually have reduced cardinality, reduced size of your data, but it's optimized for long retention. You can query over multiple years, for example. And there are additional use cases you can solve with that, because you basically have a fleet view of things. You look at all your clusters you're having. So you can have global alerting, but you also can run analytics against this data. And we use it basically also for telemetry. We look at that in a second, and for things like billing. So let's look at the first Red Hat use case here, which is telemetry and analytics. On the right side, I've listed the interesting open source projects around that, which we're using here. Some of them are Red Hat initiated, some are coming from CNCF or wherever. So telemetry, this is for understanding basically customer needs and trends. We look at observability data. So each OpenShift cluster sends telemetry data back to our central Red Hat observability service, which is based on Thanos. We'll look at the architecture later. So we get product usage metrics. We can do things like proactive incident detection. If we see things are going wrong for a customer, we can help them proactively. We can use that data for upselling. So if we see, so this customer is also always using their resources at the limits, we can suggest maybe scaling. We can use it for optimization. People waste their resources, we can suggest to optimize their stuff. And of course we can have data-driven product decisions like, we're seeing data about how optional Red Hat operators are used for customers. We can focus our development teams on these kind of things. So let's look at how the telemetry architecture looks like. The right side is basically the receive architecture from Thanos, which you've just seen, plus an export to an additional system we call Data Hub for really long-term retention and analytics questions. And there's something additional. Here's an additional API in between. This is the so-called Observatorium API. Observatorium is also an upstream project, which basically provides an API layer for observability platforms, which is multi-tenanted, which provides authentication, which basically answers all the questions which you have when you run a big multi-tenanted system which is facing customers. So the customer clusters send this to a so-called telemeter server. This is also an upstream project from Red Hat, which basically does, authentication, identification of the clusters. And then this data goes to our Thanos setup. Right, next use case, billing. This is also interesting, I think. Also based on data which goes to our central Red Hat observability service. We use that, for example, for RHEL on hyperscalers. So if you go to AWS and provision a RHEL instance through the marketplace, you'll be billed on a fine-grained level for your usage of the subscription. So on these RHEL instances, there's a so-called host metering client running. You can also find it here. And this host metering client basically scrapes host metrics like CPU, number of CPUs, number of GPUs also, because it's also part of the subscription, uptime, how long this thing's running, and forwards it to our central storage for billing then. Right, and then third use case, which I want to show, is fleet management. Fleet management is a lot more than observability, but observability is a big part of that for us. So this is basically the use case where you're centrally managing a large fleet of clusters. And you use observability data for things like looking at your SLOs, checking whether that fleet is inside your error. So everything is inside your error budgets. When things go wrong, you can have global dashboards for everything. Of course, central and global alerting. This is also good for incident detection and for optimizing your fleets. So the interesting projects here is our open cluster management. This is where our multi-cluster product, advanced cluster management, is based on. And as part of that, the multi-cluster observability operator, which basically provides that architecture, which you will now see in for advanced cluster management, and again, Observatorium and Thanos. So let me look at that a bit more in detail. So in general, we're trusting, in that use case, we're treating clusters as cattle. So hands up, who's aware of that analogy? Pets versus cattle. Okay, so many, so I'll explain a bit. So it's basically an analogy from agriculture. So if you have pets, so your dog, your cat, you give it a name, you care about it, you are sad when it's sick, you're very sad when it dies. And cattle is the exact opposite. You have a cow, it has a number, you want to get some money from it, but when it dies, you just replace it with a new one, right? Now, this is how we try to treat clusters in that use case. And that's the architecture. I know it looks a bit complicated, but you basically have on the left side again the Thanos receive architecture. I flipped the architecture diagram this time so that you don't fall asleep. Oops, sorry. So there's again the Observatorium API here with the source clusters, but this time these are, for example, internal teams running managed services for OpenShift. And we give them access to this thing we call monitoring as a service. So they choose to send their metrics to that central place, and they additionally get the opportunity to query the metrics as well, and also configure their own Prometheus rules through the Observatorium API. So they get a Grafana where they can look at their data for their servers, and they can do alerting there. We do that for many services internally, and we also ship that to customers. That whole architecture, we package it into our advanced cluster management product using Open Cluster Management and ship it to customers. So you can run it on your own infrastructure, basically that monitoring as a service approach. We have big customers who use that, who have thousands, tens of thousands of clusters which they manage with this thing. Good, but if you look at that, you can probably imagine that there's a lot of operational effort involved in that, both for us and when you ship that to customers, also for the customers to find the right scaling, the right configuration for their use case. So there's really people effort involved. So this is kind of a gap we want to close a bit, at least, with a new project we've now started. This is the Thanos operator. It's a new upstream project, just started half a year ago. So we're planning to use that in our products and also for our internal use cases. It's basically an operator. So hands up, who's aware of the operator paradigm in Kubernetes? Yeah? Okay, maybe let me also explain a bit. So an operator is basically a thing you deploy on Kubernetes, which has the operational knowledge baked in to run a certain thing. For example, a famous operator is the Prometheus operator. An operator extends the Kubernetes API with new objects. So when you install the Prometheus operator, you get new API objects like Prometheus rule, like service monitor, which you then can use to spin up a Prometheus stack. So you basically create just a YAML file with the kind Prometheus, and the Prometheus operator takes care of really installing the Prometheus in a highly available way, creating a configuration for it, making sure that it runs, and then you create a service monitor object, again, a YAML file with a kind service monitor where you specify the service you want to monitor. You just push it to Kubernetes. Kubernetes takes care of the rest. Prometheus operator changes the Prometheus configuration in order to scrape that service and integrate it. You're basically only writing YAML files, and the operator takes care of the rest. So we want to have something like that for Thanos, that you basically then have a Thanos object, which you give a few configuration options, and the operator then takes care of the scaling. There can be something like t-shirt sizing in there. We just say this is a cluster where we, for a medium-sized fleet or for a large-sized fleet, for an extra large-sized fleet, which then leads to different configuration options inside Thanos for different scales of the receive hash ring and stuff like that. So this is already at a state where it can install all Thanos components, supporting that receive architecture. It plays well with Prometheus operator, and in the future, as I said, we want to have something like t-shirt sizing and auto discovery for object store, auto scaling, and also being able to pause single components. If you're interested, look at that repository. We're always happy about contributors. Good. Last topic is a quick comparison between do-it-yourself and vendor solutions. I stole that from a talk from one of my team, or two of my team members from PromCon 2022. So if you want to watch that full talk, go here. They were basically also talking about monitoring as a service and trying to compare costs. When you run that on your own, your self-hosted infrastructure fully built on open source, compared to just using a vendor solution. So they have used data from Grafana Enterprise, from Google Managed Prometheus, from AWS, compared to our own setup. This is data from 2 years ago, so prices might have changed, but at least it gives you an idea of the scale, at least. So this was for the question of running 10 million active series and scraping them, which are scraped every 30 seconds, and comparing the infrastructure need. So this is on the top, on the bottom, you see the need for this for us on AWS, 300 gigabytes of memory, 15 CPUs, 5 nodes, 400 gigabytes of disk. Doesn't feel so much. So this is the cost comparison. For Grafana, we have two numbers. One is the public calculator on the website, and one is from talking to Grafana people about a negotiated rate. So it's a lot lower. So also as an advice, always talk to the people. Don't trust the price on the website. But you see the do-it-yourself is so much less. Of course, there's many, many more things involved in the do-it-yourself thing, right? Do you need the people to run that, right? But it just gives you a comparison. And the larger the scale you get, the more probably you should think about whether that's the right thing to do. Right. So that's basically it. Are there any questions? It was a bit quicker. You can go to lunch earlier.
Thank you, Daniel, for your presentation showing us how to do multi-cluster observability with open source tools. So we have plenty of time for questions, so feel free to ask them right now. Are there any questions? Okay, then I have a question.
Yeah.
Since you have such big multi-cluster systems, how many metrics do you observe?
Right, so for our internal services, for basically the managed services we run, the largest thing we have is a service called hosted control planes on OpenShift. It's basically where you can host the control plane of Kubernetes inside a Kubernetes cluster, which is just cost efficient for very large installations. So the largest customers use that. So we're talking about thousands to 10,000s of clusters we're monitoring with that. We have 200 million active series for that currently, scraped every 30 seconds. So in that example here, it's basically the 20 times that per month. So yeah, this is where we really can save a lot of money.
Thank you. Are there any other questions? Okay, well then, thank you, Daniel, for your talk, and give him a big applause, please.
Thank you.